Here we go, Algebra 2 students. This is another Regents review video. This is the Algebra 2 Common Core exam for January 2018. These are going to be the solutions to Part 1, questions 1 through 12 of this exam. By far, in my opinion, one of the more difficult and challenging Algebra 2 exams. So, with that being said, do not, under any circumstances, take my answers that I put time and effort into and take them and put them on a piece of paper and call them your own, because we all know that the multiple choice, there's really no work shown out on the internet except, these videos. So don't do it to get homework done. It's so not worth it because you need to pass this exam, right? Yeah, that's important. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate it. I like to keep this channel going for quite a long time, so a little monetary donation will be much appreciated. And make sure that you visit my website at www.nysmathregentsprep.com for more math content in Algebra 2 and your future mathematical subjects. And of course, I use the TI Inspire CX calculator. This link can be found on my website. It links you right to Amazon, or you could purchase the calculator online computer software that I use in these videos. So without further ado, let's begin this exam. All right, we begin with an easy question. Number 1 says, the operator of the local mall wants to find out how many of the mall's employees make purchases in the food court when they are working. She hopes to use these data to increase the rent and attract new food vendors. In total, there are 1,023 employees who work at the mall. The best method to obtain a random sample of the employees would be to survey what? So we have to think about what the operator of the mall is doing. Well, she wants to take a random sample, and she wants to find out how many of the mall's employees make purchases in the food court. So she's looking at, all right, how many people do not bring their own lunch? They go ahead and buy lunch at the food court. Well, she is looking for a random sample, okay? What's the most random? What has the least bias? Well, take a look at choice 1. All 170 employees at each of the larger stores. That's bias. That means that the mall operator is not asking any small, locally owned businesses like, thrift stores or anything like that. They're asking for larger stores. If you've been to the mall is kind of dying by me, but there are some big malls, like they have Macy's. They had, or still have, Sears. I don't know if that's still a thing. Macy's. I said JCPenney yet? I'm not so sure. There's a lot of stores. But basically they have like all these stores, the big brands. Bloomingdale's, that's a big one, I know. But that's a bias. They're only asking those people? Come on. That is completely biased. Choice 2 says 50% of the 90 employees of the food court. Well, what, you're just surveying half of the 90 employees in the food court? Well, I'm sorry, they might buy the food court food because they might get a discount. So that obviously creates a bias. That's pinpointing what type of people or what types of people to survey. Every employee. Okay, that was certainly the trick answer. Every employee, that is not the best way to do a randomized sample, okay? By doing an every employee, that's a census. That's not a survey. Choice 4 is the better answer of the two. Every 30th employee entering the mall entrance for 1 week. This is randomized. Okay, this is the most random. And that's what we want. We want the most random. We don't know who's going to be walking into the mall entrance. We could talk about clothing stores, food stores. We could talk about, a mixture of things like Walmart. That has everything. So that is a randomized survey. We don't know who's going to walk in, but we know for sure that is not going to create as large of a bias as the other 3 answer choices. So your answer is going to be choice 4 for that question. Number 2, what is the solution set for x in the equation below? So in order to do this question, you want to isolate the radical. The reason why you want to isolate the radical is you want to solve for x. and you cannot solve for x when it's stuck underneath the radical sign. So what we're going to do is, first off, I need to rewrite this. So we have x plus 1 minus 1 equals x. The first thing that we're going to do is we're going to add the 1 on both sides. That's important. The square root of x plus 1 is equal to x plus 1. Okay. Now, in order to get rid of the square root, we are going to square this. And once we do that to one side, we must do it to the other side. So, when you square a square root, well, those things just cancel. You're left with whatever's in the radicand. So we have x plus 1, right? This is equal to x plus 1, x plus 1. Just write it twice. That's raised to the second power. Now I'm going to FOIL, or distribute. So we get x plus 1 is equal to x squared plus 2x plus 1. Now we solve for x. Subtract that x, subtract the 1, subtract the x, subtract the 1. And here we go. We get x squared. 2x minus x is just positive x, and 1 minus 1 just cancels out to 0. So we have x squared plus x is equal to 0. Okay, let's continue to solve for x. The best thing to do is take out a GCF, take out an x. We're left with x plus 1. Set that equal to 0, and now do your classic t-bar. We get x equals 0, and x is equal to negative 1. So these are your possible solutions, but now what we need to do is make sure that they check out. So I am going to perform a check. To make sure that both of these answers work, you have to check your solutions. Let's plug in x equals 0, and let's see if that works. So I'm going to plug it into the square root of x plus 1 minus 1 equals x. Well, when we plug in 0, we have the square root of 0 plus 1 minus 1 equals 0. Well, this is just the square root of 1 minus 1 equals 0. The square root of 1 is just 1 minus 1 equals 0. Well, 1 minus 1 is 0. Does 0 equal 0? Of course it does. So we know for sure that x equals 0 checks out. Let's go ahead and try the other possible solution. Okay, so let's try x equals negative 1. Let's go ahead and plug that in. So we have the square root again of x plus 1 minus 1 equals x. Let's go ahead and plug in negative 1. We have the square root of negative 1 plus 1 minus 1. Does that equal negative 1? Well, the square root of negative 1 plus 1, that's just the square root of 0, which is just 0, right? So that's just 0 minus 1 equals negative 1. Negative 1 does equal negative 1, so that definitely checks out as well. So we know that this is also a solution. So your answer is going to be choice 3 for that question. Not too bad of a question. You just have to make sure that you check your answers. All right, your answer is choice 3. Moving on. For the system shown below, what is the value of z? So what we are going to do is think smart. We got to think smart about this question. I see a couple things here. I see a y equals this. Okay, that looks good so far. Then all of a sudden, I have 3x minus 4z equals 2. All right, I see a z in there. That looks nerve-wracking. And we have 3x minus y equals 16. What do you think that the better option is? Well, I could already see it. I am going to actually take the top equation, which is y equals negative 2x plus 14, and I am going to use substitution. I'm going to substitute this equation into my y over here. What does that do for us? Well, we have everything in terms of x, which is good for us. So I took this, and I'm plugging it in here. So what we get is the following. 3x minus, in parentheses, watch out for that negative sign. You have to put this in parentheses to get the right answer. Okay, so what I'm going to do is I'm going to take that negative 1 and distribute it inside. So we get 3x plus 2x minus 14 equals 16. Now we continue to solve for x. We get 5x minus 14 equals 16. Add that 14 on both sides. We get 5x is equal to 30. And we get x is equal to 6. Now, why am I doing this? Well, we're trying to solve for the value of z, right? Now, what's nice about this is you don't even need to find the value of y. We just don't need to. Because if we have the value of x right here, we have the value of x equals 6. Watch what I'm going to do. I'm then going to take my x, if I make this the right size, I'm going to take my x, plug it way back in up here into the pink equation. Look, if you plug in 6 in for x, you just have everything in terms of z. So that's good. Let's go ahead and solve for it. When we solve for this, we get 3 times, now I'm plugging in 6 in for x, we get 3 times 6 minus 4z equals 2. Great. 6 times 3 is 18 minus 4z is equal to 2. I am now going to solve for the value of z. Subtract the 18 on both sides. We get negative 4z is equal to negative 16. That's good so far. Divide by that negative 4 on both sides, and I get z is equal to positive 4. Ladies and gentlemen, that is the answer to this question. Your answer is going to be choice 4. Now, I know that wasn't that bad, but I want to show you a way on the calculator to make your life a little bit easier, just in case you don't know how to solve this problem. You're going to open up your TI Inspire CX calculator. You're going to go to the calculator page, go to Menu, go to Algebra, and click on Solve System of Linear Equations. Now, as you can see here, we have only 2 equations. Well, on our paper, we have 3. So I'm just going to up this to 3, and now everything's in terms of x, y, and z. That's good. I am now going to type in my 3 systems of equations. So I have y equals negative 2x plus 14, down arrow. I get 3x minus 4z is equal to 2. And do it one more time. 3x minus y is equal to 16. Now when you press enter, voila, it gives you every answer. It tells you what x is equal to, which we already found before, what y is equal to, and what z is equal to. So the order of 6, 2, and 4 matches the order of x, y, and z. So it's just corresponding to each other. X equals 6, y equals 2, z is 4. Great. So that's just a backup way to make sure that you check your answer. Make sure everything's good to go. All right? Your answer is choice 4 for that question. Moving on to number 4. The hours of daylight. Why in I can't pronounce this name. Is it Utica or Utica? Someone from that area, please let me know how it's pronounced. In days x from January 1st, 2013, can be modeled by the equation y equals 3.06 sine of 0.017x minus 1.40 plus 12.23. How many hours of daylight to the nearest tenth does this model predict for February 14th, 2013? So, there's a couple things that we got to do here. First things first, I need to plug this into my calculator. All right, that's probably the best thing to do first. Stop what you're doing, go to your calculator, let's go ahead and graph this puppy. So we have 3.06 times the sine of 0.017x minus 1.4 plus 12.23. Okay. I really don't care how it looks. All right, we can't even see it. Let's go to menu, Windows zoom fit. Oh, that's a pretty big sine curve. Let me zoom out a little bit more, just to see, because it technically is a sine curve, so it should look something like a sine curve. It's a big sine curve. Okay, so that's how it should look. It's big, but you know, that's okay. We could deal with it. But that's really, I don't really care about that. But it says here, how many hours of daylight to the nearest tenth does this model predict for February 14th, 2013? Well, it says here at the top, the hours of daylight y in this town, I cannot pronounce it. I'll just go with Utica. Utica in days X from January 1st, 2013. So that means that X is equal to 0 is January 1st. Okay? So that's when X equals 0 because we're basing it off from January 1st. I know it sounds crazy. You're like, why isn't X equal 1? Because that is the starting point on the X values for this sine curve, okay? Now, it goes to February 14th. Well, how many days is that? Well, here's what you got to know. There's 31 days in January. There's 31 days in January. And there are, now we don't really care what February is because it's in the middle of the month. Well, we go 31 days plus, and I know this sounds crazy, but we're adding 31 plus 13, which is 44. You're probably saying to yourself, why not add 14 days? Because we want to figure out on the 14th day. So this is really x is equal to 44 is actually indeed February 14th, 2013. All right, so now what we're going to do is they're basically saying how many hours of daylight to the nearest 10th does this predict for February 14th. So it's asking you, what is the y value when x equals 44? That's what we're looking for. And that is code, math language, to find f of 44. Now, if you go to your graphing calculator and click on Control T, go down to when x is equal to 44. It's kind of a long way down. Now, what's crazy about this is how many of you fell for the trap of 12.2? How many of you fell for the trap of 12.2? That is actually not your answer. That is wrong. And the reason why is this. Most of the time, your calculators are in degree mode. For the sake of this problem, and I know it sounds mean, your calculator had to be in radian mode for this. But look, if I do Control T, look at the top, it switches it to degree mode. That's not what we want. So what I'm going to do is I'm going to press the home button, click on settings, document settings, and I'm going to change this temporarily to radian mode. I'm going to make this default and click OK. Now watch this. When I go back to my page, click it again, Control T. Now, those are completely different numbers, ladies and gentlemen. Completely different numbers. Go down to 44. Now, if you don't want to do this on your Regents, I'll show you another way. Your answer, by the way, is 10.37, which is 10.4. That actually is your answer. It's choice 2. But if you want to do this differently, just click on Control Doc and add a calculator page and type in F1 of 44. Now, just understand that I have this stored in F1. Yours might be F2, F3, F4, whatever you're doing with it. Make sure it's corresponding to the function that you have. In this case, it's F1, and as you can see, it's 10.3. Now, if I had this in degree mode, it's not going to give you the right answer, so you just have to be so incredibly careful. Generally speaking, when you're dealing with sine, cosine, or tangent graphs, and it's asking you for a value of y, put your calculator in radian mode. That's important stuff. I don't know if many teachers emphasize that, but you have to put your calculator in radian mode for that, or else you're not going to get the right answer. Moving on to number 5. A certain pain reliever is taken in 220 milligram dosages, and has a half-life of 12 hours. The function A equals 220 times 1/2 raised to the t divided by 12 can be used to model the situation where A is the amount of pain reliever in milligrams remaining in the body after t hours. According to this function, which statement is true? So, of course, we are looking for the true statement. Well, what is the true statement? We got to figure that out. Choice 1 says, every hour, the amount of pain reliever remaining is cut in half. So what they're telling us is every single hour. So when you plug in t equals 1, for example, when you plug in t equals 1, there should be a remaining dosage of 110 milligrams in your body. Really? When you plug in t equals 1, does that work? Take 220 times a half and raise it to the 1/12 power. It should give you 110 if that's true. It only gives you 207. That only cuts it by 13 milligrams. That makes absolutely no sense. So that's false. Number 2 says in 12 hours, there's no pain reliever remaining in the body. Now, I don't even need a calculator for this. It says in 12 hours. So if I let t equal the number 12, you're telling me that there's going to be nothing remaining left in the body. Well, let's see about that. A is equal to 220 times a half raised to the 12 divided by 12. Well, 12 divided by 12 is just 1. So it's A equals 220 times a half. No, there's 110 milligrams left. That's false information too. So that can't work. Let's go ahead and try choice 3. In 24 hours, there is no pain reliever remaining in the body? Well, let's go ahead and plug in 24, shall we? A is equal to 220 times 1/2 raised to the 24 divided by 12. That's going to be 220 times 1/2 raised to the second power. Well, that's just 220 times 1/4. And I know darn well that that is not equal to 0. I can't remember what it is. I think it's 55. If I'm not mistaken, I believe it's 55. 220 times 1/4. Yep, 55. So there's 55 milligrams in the body left. So let's take a look at choice 4 and see why that's true. Oops. My apologies. It says here in 12 hours, 110 milligrams of pain reliever is remaining. Well, let's figure that out. A is equal to 220 times 1/2 raised to the 12 divided by 12 when t equals 12. Well, 12 divided by 12 is 1. A is 220 times 1/2 raised to the first power. Well, what's 1/2 of 20? Of 220, I should say. That's 110 milligrams. Ladies and gentlemen, your answer is choice 4 for that question. Just take it slow, go through those answer choices, and they will make sense. Number 6, the expression x plus a, x plus b cannot be written as what? So basically, we're just going to go ahead and distribute this and see what it does equal. And we'll just compare it to the rest of the answers. Okay? We're going to distribute these. We get x squared plus bx plus ax plus ab. This, ladies and gentlemen, is the answer that this results in. So, which of the following answer choices is not correct? Now, if you're smart about it, just by looking at this, I know it's choice 2. Just by looking at it, it's choice 2. The reason why is, you know what's bothering me? This middle term. How in the world did they somehow combine the a, the b, and the x and multiply them all together? How is that possible? How is that possible? Just by using the distribution method. We get bx and ax. Those are actually not like terms, folks. A and b are two completely different integers. No, I'm sorry, letters, but they could be, all right, well, not even letters, they're different variables. You cannot combine a and b. We don't even know if a and b are integers. If they said that somewhere, then yeah, that might be true, you know. Actually, no, it couldn't, because we have to add those together anyway. So that's just so troubling. If you take a look at all the other answer choices, they match what I just boxed here in blue. So if I were to quickly show you what everything else yields to, choice 1, for example, you distribute that a in, distribute the x in, you get ax plus ab plus x squared plus xb. If you just quickly shuffle around and rearrange this, this is the same thing as x squared plus bx plus ax plus ab, which is actually the same thing as what's over here. If you take a look at choice 2, again, just distribute, and if you do a quick shuffle, this is x squared plus bx plus ax plus ab. So that is true. And if you take a look at choice 4, distribute these and shuffle them around. This is just x squared plus bx plus ax plus ab. And that is also true. Choice 2, there is no way that you could combine the a, the b, and the x and multiply them all together. So your answer for this question is going to be choice 2. Moving on to number 7. There are 440 students at Thomas Paine High School enrolled in U.S. history. On the April report card, the students' grades are approximately normally distributed with a mean of 79 and a standard deviation of 7. Students who earn a grade less than or equal to 64.9 must attend summer school. That will be you if you're cheating right now off of these videos, so please don't do it. The number of students who must attend summer school for U.S. history is closest to what? So, when you hear the terms mean, standard deviation, normal distribution, and the hold on, I'm looking for another number. Oh, lower and upper bounds. You are thinking of this. Normal CDF on your calculator. Very important. Normal CDF in your calculator, when you see this type of problem, that's what you're thinking of. So I'm going to go to my TI Inspire, And I'm going to go to my calculator page and click on Menu, go down to Statistics, go to Distributions, and then go to Normal CDF. Now, think about this critically here. The lower bound. Well, what is the lower bound? What is the lowest possible grade that you could get in school and attend summer school? Well, that number is 0 if you don't go to class. That's your lower bound. Your upper bound is going to be 64.9. And your mean, well, they tell you that the mean is 79. And your standard deviation is 7. So type all this information into your calculator. Type it all into your calculator. So this is going to be 0. That's not 0. That's 1. 0, 64.9. Your standard deviation of that's your mean. Your mean is 79. Yep. And your standard deviation is the number 7. Click OK. Now, what is this number? Well, this is a percentage. So it's saying that 2.2% of the people in this grade is going to go to summer school. So, again, this is 2.2% of people who are going to summer school for this class. So in order to get the number of students who attend summer school, you're just taking 440 students and you're multiplying it by 2.2%. Now, you can use a percentage button on the calculator, but this is really 440 for those of you using the TI-84. This is 440 times 0.022. Okay? So that is obviously the closest. So I'm just going to take 440 and multiply it. I'm just going to copy and paste this whole number. There are 9.67 students, so you round this up to 10 students. That is the closest number of students who will be attending summer school for United States history. Your answer for this question is choice 3. Moving on to number 8. For a given time x in seconds, an electric current y can be represented by y equals 2.5 times 1 minus 2.7 raised to the negative 0.10x. Which equation is not equivalent? So I assume that they're testing your knowledge on exponents. And yes, they are. Everything is manipulating in here. So what we got to think about is, well, which one is the one that's not equivalent to the original? Well, take a look at choice 1. This is saying 2.5 minus 2.5 times 2.7 raised to the negative 0.10x. Well, all they did, very easy. All they did is they just distributed that 2.5 inside. They did 2.5 times 1, which is 2.5. And they just decided to leave this unsimplified. They just said, all right, it's just minus 2.5 times the 2.7 times negative 0.10x. So that is actually true. That is equivalent. That's not your answer. This one over here. So it looks like that they distributed again, but now we have something going on in here. What's going on? Well, all they're doing is they're using your knowledge of the power-to-power rule of exponents. Remember the power-to-power rule. If you have x to the m raised to the n, that is the same thing as saying x to the mn. Okay, that is your power-to-power rule. Something on the lines of that effect. I think on my study guide I use a different I use different letters to represent those. But basically what you're doing is you're multiplying these numbers here, the 2 times the negative 0.5x. Well, we know that that's just going to be negative 0.10x, which is true because that's what we have up here. So this is actually equivalent as well. This one over here, this one's testing your knowledge a little bit differently. This is testing your knowledge on whether or not you understand that you could move exponents up and down. Notice how this exponent is positive? Well, if you shift it right back up here, it becomes negative again. So this is 2.7 raised to the negative 0.10x. 110%, that is absolutely true. That's equivalent. Your answer is choice 4. Let's figure out why. So it looks like that they distributed properly. Okay. This is not the power-to-power rule, folks. This is not it. Look at what they're doing here. They're testing your knowledge on whether or not you understand the difference between the power-to-power rule and you're multiplying things with the same base and you're adding the exponents. This right here is not doing anything on the lines of raising it to the negative 0.10x. They want you, honestly, they want you to multiply negative 2 times the 0.05x. Well, this is equal to 2.7 raised to the negative 2 plus 0.05x. That's total BS. That's not true. And that is not equivalent to negative 0.10x. Now, if we just combine this a little bit further, this is really 2.7 raised to the negative 1.95x, which is not equivalent to 2.7 raised to the negative 0.10x. Now, let's just say you didn't like what I just did with the exponent rules. You really should, because that is the right way to do it. But if you go to your graphing calculator, no worries, go to your graphing calculator and type in the original equation, which is 2.5 times 1 minus 2.7 raised to the negative 0.10x. Graph it. Fine. Now graph choice 4, 2.5 minus 2.5 times 2.7 to the negative second power times 2.7 raised to the 0.05x. And look at that. It's not even close. Not even close. Everything else, by the way, everything else for those answer choices, they will very nicely overlap that blue graph. So your answer for this question is choice 4. Moving on to number 9. What is the quotient when 10x to the third minus 3x squared minus 7x plus 3 is divided by 2x minus 1? Okay. I am sorry to tell you this, but it took me like 5 exams to do this. I was looking back, like I always go back and look at my videos and see how else I could improve things. I have failed to mention, every time I've done one of these questions, I have failed to mention that when you perform synthetic division, because that's what we're actually going to do, when you perform synthetic division, the thing that you're dividing by has to be in the form of x minus a, okay? Where this has to be a coefficient of 1. Now, there are 2 options that you could do to solve this question. You could either do long division, which I hate. Oh God, I hate long division of polynomials. Or you could do synthetic division. Now, if you're using synthetic division, you have to be very, very careful. I'm actually going to use synthetic division. I am going to take this, 2x minus 1, and I'm going to set it equal to 0. That's the standard procedure to start the synthetic division process. I'm going to add that 1 on both sides, and we get 2x equals 1. I'm going to divide by the 2, and we get x is equal to a half. Now, typically, mathematics teachers say, all right, put the 1/2 in your little window or the box, and you take the coefficients without skipping anything. So you take the coefficients of 10, negative 3, negative 7, and 3. Draw your lines here, bring down that 10, and start your synthetic division process, which I have been teaching it like that for years. Well, I'm going to show you something that I keep failing to mention every time I do these problems. When why am I drawing a blank on what this is called? It's the, oh, I'm sorry, yes. It's called the divisor. I don't know why it's late. I drew a blank. I don't know why I drew a blank. It's called the divisor. When you're performing synthetic division, your divisor is supposed to be in the form of x minus a, where the leading coefficient of x is the number 1. But, as you can see, it's the number 2. Forget that for a second. I'm going to perform synthetic division. 10 times a half is 5. 5 plus a negative 3 is positive 2. 2 times a half is 1. 1 plus a negative 7 is negative 6. Negative 6 times a half is negative 3. Negative 3 plus 3 is 0. So, what I always said to you is, say, all right, this is 10x squared plus 2x minus 6. Now, here's the deal. Most math teachers tell you that that's your answer. That if your math teacher has been telling you that, you better correct them. That is completely incorrect. You are not allowed to write that as an answer in like a part 2 question if it's asking for your short response questions. And your math teachers probably taught it to you like that and maybe overlooked it, but that is absolutely incorrect. And I'll prove it to you right now. If I take this polynomial and divide it by the 2x minus 1 in my graphing calculator, I want you to visually see what's going on here. So this is going to be 10x to the third This is minus 3x squared minus 7x plus 3 divided by 2x minus 1. And we get this, right? We get a quadratic, and that makes sense, right? Because when you divide polynomials, it should drop by 1 degree. So if you have a cubic first and you're dividing by a linear term, you should be getting a quadratic. Well, watch what happens when I type in 10x squared plus 2x minus 6 into my calculator. Ladies and gentlemen, that does not match at all. That doesn't match. That is not synthetically divided properly. Now what went wrong? It's not that we synthetically divided incorrectly. It all goes back to this condition that I said to you up here. The divisor has to be in the form of x minus a. So, the correct answer is actually 5x squared plus x minus 3. That's the correct answer. But why is it the correct answer? Well, you need to take your answer that you got here, and you need to divide by what is in the front of the x, and that will fix the whole problem for you. We're going to divide everything by the number 2, and this gives us an answer of 5x squared plus x minus 3. And that, ladies and gentlemen, is your answer. Your answer is choice 4. Just to show you in the graphing calculator on how that would look, if I go back up here, and I change all of these to its proper number, so this is 5. That's nothing over here. That's just a 1. Oop, that's just a 1. What am I doing? That's just a 1. It's a 5. And this is a 3. Watch this. Perfectly overlaps the blue equation. So, again, don't say that Trevor is yelling at your math teacher, because I'm not held responsible. But if your teacher has been telling you, oh yeah, it's just 10x squared plus 2x minus 6, tell them that they're wrong, and they need to correct themselves and make sure it's 5x squared plus x minus 3. So your answer is choice 4. I didn't clarify that on like other videos. I had to make sure that I did. Number 10, Judith puts $5,000 into an investment account with interest compounded continuously. Which approximate annual rate is needed for the account to grow to $9,110 after 30 years? The key words here, folks, are compounded continuously. When you hear the words compound continuously, you're thinking of the classic formula of PERT. A equals PE raised to the RT, where E is just Euler's number. So, what do we do? Well, they want the account to grow to $9,110. So that's actually your A. Your A is $9,110. She puts in $5,000 first. So your principal, which is your starting amount, is $5,000. And your time is 30 years. We're trying to solve for the rate. So we need to use logarithms because r is in the exponent. You need to solve for r. We're going to be using logarithms. Sorry, I know that most people don't like logs. So you have 9,110 is equal to the principal of 5,000. E raised to the rate times 30. Let me write that a little bit cleaner. It's just rate times 30. That's just going to be 30r. All right? So the first thing that we want to do is solve for r. But in order to do that, we actually need to divide by whatever stuff is in the front of the e. So I'm going to divide by 5,000. Divide by 5,000 on both sides. 9,110 divided by 5,000. When you simplify that in the calculator, well, you just cancel out those zeros. You get 911 over 500 is equal to e raised to the 30r. Now, we need to solve for r. Great. I'm going to take this 30r. I'm going to move it down in the front. So I get 30r. But when you write down 30r down where e is, and you move that exponent down into the front, you have to write the word log or ln. Now, log and ln essentially at your level mean the same thing. One stands for log, one stands for the natural log. I don't want to get into technical terms, but the natural logarithm has a base of e. But when you see the letter e, it is in your best interest to use natural logarithm. So you write ln of e. Just understand in your brain that ln in this case means log. Okay, now what you do to one side of the equation, you must do to the other side of the equation. So you have to take the natural log of this side. Okay, now you should know that the natural logarithm of e just reduces to the number 1. Well, and as I said before, the natural log has a base of e. And what is the natural log of e to the e? Well, you're thinking to yourself, what number, when e is raised to what number, how does it equal e? Well, e raised to the first power equals e, so that's why it's equal to 1. And if you don't understand anything that I just said, just type ln of e into your calculator and you will get the number 1. Now we need to solve for r. Divide by 30, divide by 30, that cancels, and you get r is equal to, you need to type all of this into your calculator and see what you get. So we get controlled division, the natural logarithm of 911 over 500 divided by 30. And we get an answer of 0.0199, which is just 0.012. So this is 0.0, actually no, I'm sorry, it's 0.02, which is just the same thing as 2%. So we're looking for one of these answers. All right, so our answers are actually expressed as percentages. So it's not this answer. It's going to be 2%. Your answer for this question is going to be choice 1. All right, and that's how you do it. Moving on to number 11. If n equals the square root of a to the 5th and m equals a, where a is a positive integer, which is greater than 0, an expression for n divided by m could be what? Oh, real quick, a doesn't have to be an integer. I'm sorry, I said integer. It just has to be a positive number. An expression for n divided by m could be what? So we need to think to ourselves. It says that n equals the square root of a to the 5th, and m is equal to a. We're looking for n divided by m. Well, essentially, we're just saying that it's the square root of a to the 5th divided by m, which is equal to a. That's really what we're doing, right? So we got to simplify this. Not too bad. This is really saying a to the 5 halves power, because remember, this has an index of 2, or a root of 2. So remember, when you write, when you rewrite radicals in the form like this, when you rewrite radicals into its exponent form, you take the radicand and you raise it to the power over the root. The power, what is being raised to, goes up top, and the root goes in the denominator. So the power is 5, the root is 2. So this is really a to the 5 halves. Okay? Now this is really a to the 2 divided by 2. Now you might be saying to yourself, why did he do that? Well, this is technically a to the 1st. Don't get me wrong. This is a to the 1st. But I'm going to make my life so much easier when I make this a to the 2 over 2. Why? Well, we need to subtract these exponents. Remember when you are dividing polynomials, you divide the coefficients and you subtract the exponents. It's significantly easier when you have like denominators immediately. So this is really saying a to the 5 halves minus a to the 2 over 2, or 2 halves. Well, that's easy. This is a to the 5 minus 2, which is 3, divided by 2. So we're looking for an answer of a to the 3 halves. Well, of course, it's not these two, but it looks like one of these. Well, they decided to put it in radical form again. Well, again, I said that this is power over root. So this is really saying a raised to the 3rd power, and just take the 2nd root, which is just the square root. So your answer is going to be the square root of a cubed, which is going to be choice 4 for this question. That's how you do it. Moving on to the last question of the video, number 12. The solutions of x plus 3 minus 4 divided by x minus 1 equals 5 are what? So it looks kind of wacky, but it's not too bad. The first thing that I want to do is move that 3 over to the right-hand side. I think that's significantly easier, right? So this is x plus 3 minus 4 over x minus 1 equals 5. I'm going to move that 3 over to the right-hand side first. We get x minus 4 over x minus 1 equals 2. Let's go ahead and find a least common denominator. Well, the least common denominator, there's only one least common denominator, is x minus 1. So I'm going to put everything over 1, and I am going to multiply by what I need. So I multiply this by x minus 1 this fraction, but what do you do to the bottom, you must do to the top. And I'm going to do the same thing over here. What do you do to the bottom, you must do to the top. Now, we get x times x minus 1 over x minus 1. I'm going to change this a little bit. I'm going to make this positive with a negative 4 up top. I never liked subtracting things. I always like to add on a negative. So this is plus negative 4 over x minus 1 is equal to 2 times x minus 1 over x minus 1. Now, what's nice about the LCD is when you have everything to have the least common denominator, you just cancel all those out and you solve for the top. You're allowed to do that in math. So I'm going to solve for x. I'm going to distribute that x. We get x squared minus x minus 4 equals, and distribute these, we get 2x minus 2. Great, solve for x. I'm going to subtract the 2x and add the 2 on both sides. Subtract the 2x and add the 2 on both sides. And we get x squared minus 3x minus 2 equals 0. Ugh, I'm having some serious doubts because, well, not doubts that I got it wrong, but I definitely got it right so far. But it's not factorable. We can't add to a negative 3 and multiply to give you negative 2. Because if I think about it, all right, well, in order to multiply to get a negative answer, you have to have a positive and a negative result. Well, negative 2 times 1 is in fact negative 2, but negative 2 plus 1 is negative 1. So there's no possible way to factor this using the trinomial method. So you have two options. Either you could complete the square or you could do the quadratic formula. It's entirely up to you. Some people like the quadratic formula, x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Or you could do completing the square. I like completing the square because it's really fast. All you do is you keep the letters on one side, numbers on the other side, and you factor appropriately. Add in a blank space, and we have 2 plus a blank space. You should be familiar with completing the square. You did it in algebra, you did it in geometry, and you're doing it now here too. So we need to figure out what goes here. So it's 3 divided by 2, which is going to be negative 3 halves, and then you square it, that's just going to be 9 fourths. 9 fourths. Yeah, this might not be a better way when I think about it. Because usually when we complete the square, this is like a nice number. That is not a nice number, I must say. I mean, you could factor it. You know what? Back it up. Back it up. Trevor doesn't think that that's a good idea anymore. So, listen, I promise you it is factorable. I am not factoring that. I'm sorry. I'm not in the mood. So let's just go ahead and use the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. Well, because the quadratic formula always works regardless. So this is x is equal to, this is your b value in the middle. So that's going to be negative 3, which is a positive 3, plus minus the square root of negative 3 square root, which is 9, minus 4 times 1 times negative 2, all over 2 times 1. And if you're having trouble keeping up with me, I'm sorry. It's not me going fast. It's you going slow. You should know how to do the quadratic formula in your sleep. All right, so we got x is equal to 3 plus minus the square root of 17 all divided by 2. Ladies and gentlemen, this is your answer. X is equal to 3 plus minus the square root of 17 all over 2. Which another way to write this, and I know because it's up in the answer choices, another way to write this is to do the I heart division method, where you just take the 2 and you divide it by each term. So this is another way of saying 3 halves plus or minus radical 17 all over 2. This is also equivalent. So your answer for this is going to be choice 1 for this question. All right. And that is the conclusion of this video. I hope that it was helpful. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate the support. And make sure that you visit my website at www.nysmathregentsprep.com for more math content in Algebra 2 and your future mathematical subjects. And I hope to see you soon.